So here are the board problems for section 2.5. Watch or pause the video, work these out, and then watch the video. So here we just have to do our derivative. Put the 3 in front, decrease it by 1. Now we'd really have to do the chain rule here. So you'd have to do the derivative of the inside, which is the derivative of x with respect to x. However, dx over dx we know is 1. Now in the next one, we're multiplying variables together, so we'd have to do the product rule. And I'm going to leave the 3 in front and then just do the product rule on the inside. So 3. Derivative of the first, which would really be a dx over dx, which is 1, so we don't need that, times the second, minus the first, or plus the first, times the derivative of the second, derivative of y with respect to x. Then we go plus, and we'd have to do the derivative of this right here. So you put the exponent in front, decrease it by 1, then you'd have to do the derivative of the inside, derivative of y with respect to x, equals, we do the derivative of the right-hand side, derivative of a number is 0. So I think at this point, I would go ahead and just distribute through to get rid of my parentheses. Now you need to get the two terms that have dy over dx's in them on one side, the two terms that don't have those on the other side. But you'll notice here you could just divide everything by 3 so you could deal with smaller numbers. So that's what I did here. So then get the two terms of dy over dx on one side. I chose to keep the dy over dx's on this side, so I had to subtract the y and subtract an x squared. Now you'll notice dy over dx is a common factor. You could pull that out. So now you just have dy over dx multiplied by something. So to get dy over dx by itself, you just have to undo your multiplication, so you have to divide. Notice, in any spot here where I wrote dy over dx, another thing I could have written instead would be a y prime. This one here, we need to find our second derivative of this. So we have a product here, so we do the derivative of the first, 2x, derivative of the inside, which would be a dx over a dx, which I won't really have to write because that's 1, times the second, plus the first, which is an x squared, times derivative of the second, put the exponent in front, decrease it by 1, multiply it by the derivative of the inside, which would be a dy over a dx, minus, and then this would just be a 2, derivative of the inside, which would be a dx over a dx, is equal to 0. So we just get a 2xy squared, because that dx over dx is 1. Here we get a 2x squared y dy over dx, or I could write y prime, minus a 2 is equal to 0. So all I'd have to do is try to get y prime by itself. So I'd have to take my minus 2 to the other side, take my 2x dx, or 2x y squared to the other side. You can also go ahead and divide everything by 2. So we will need to get this by itself. So you'd want to subtract these to the other side. Subtracting negative 1 would be adding 1, subtracting your x squared. And then you want to get your y prime by itself, so you'd have to undo timesing by this, so you divide and you would get this here. So that's your first derivative, and you might be thinking we're halfway done because we have our first derivative. All we have to do is our second derivative. To do our second derivative, notice that this is a quotient, so we'll have to do the quotient rule. But within the quotient rule, you're multiplying variables, so you'll have to do the product rule. So we'll do our second derivative. So y double prime equals Well, derivative of the top, well, that would be 0, then minus, and then we'd have to do our product rule. So 0 minus, do our product rule. Derivative of x, you know, is 1 times the second plus the first, which is x, times the derivative of the second, times the derivative of the very inside, which would be a y prime. So that's derivative of the top times the bottom now, minus the top. Now we have to do the derivative of the bottom. Now remember, this is what was on the bottom, so we'd have to do a product rule again on that because you're multiplying variables together. So derivative of the first times the second plus the first times the derivative of the second. And the second here is your y, so that's a y prime when you do that, over your bottom squared. So at this point, I would probably do a double distribution, distribute through your negative, distribute through this. Then I'd have to FOIL this out. And distribute through the negative. Well, when you do all that, you would get something along these lines here. Then you'd want to say, oh, do I have any like terms? Well, hunky-dory, by George, we do. Here, x squared y cubes. And then you'd say, do we have any other y terms? And you'd say, hoo-yah. Here we have an x cubed y squared y prime, x cubed y squared y prime. So we could combine those together along with these two that don't have like terms. And we would get this. Now we need to still get this where y prime is on one side, or not y prime, but where there is no y prime in here. So we'd have to go ahead, and I think at this point I'm going to go ahead and take an x out of everything, thinking that might make it simpler. So you'll notice there's an x in everything on top and on the bottom. So I'll have an x So now each one of these y primes, I need to go ahead and replace with what it is up here. So I need to plug that in for each one of these. So I'm going to go ahead and write down the black. Now, instead of writing y prime, I'm going to write what this is right here, which is a 1 minus x y squared over an x squared y. Same thing in this spot. So now I actually have these red fractions in the top of a bigger black fraction. I don't want to have fractions within a fraction, so I'm going to multiply the top and the bottom by an x squared y, which is really a special form of 1. I chose that because x squared y is my denominator here. It's really an x squared y over 1 and an x squared y over 1. So if I take this, distribute it onto here, that would be an x cubed and a y to the fourth minus Now, when I take this and distribute it onto here, all it does is cancel out the bottom, leaving me only with this right here times the top. So I'm going to distribute that through negative x squared y squared onto the 1. Negative x squared y squared onto the negative xy squared would be plus. Then I'll come along and I'll take this, distribute it onto here, which would be a negative 2x squared y. Now I need to take and distribute this onto this whole term right here, which cancels out the bottom, leaving me only with this negative x times the top. So take negative x times the top. Still over the bottom. Now the bottom is what we had here in black, still times what we have over here. So I have an x cubed y squared times an x squared y. So that's an x to the 5th and a y cubed. So I'm going to check to see if I have any like terms. You'll notice I do have some like terms of here. And I have like terms of here. So I should be able to put those together. Looking at the highlighted green, that's 2 of those. Looking at the highlighted blue, oh, one's positive, one's negative, they drop out. So then I'm going to have to just bring down the next 2 things. Over my common denominator. Notice there's an x in everything top and bottom, so I should be able to simplify that. Take an x out of everything. So now let's go ahead and find our second derivative at this point. So if that's the case, all we'd have to do is plug in our x being 1 to each one of these x's, and our y being the square root of 5 into each one of these y's. So if you replace all your x's with 1 and all your y's with the square root of 5, in this case you would get 39 over 5 root 5.